Here's the second part. We're showing how two triangles are congruent. And as a reminder, this thing is the congruent symbol. So there's three ways to show that two triangles are congruent. The first one is having three sides, which is also commonly abbreviated as SS. So side, side, side in geometry is a shortcut for if each side of one triangle is congruent to the corresponding side of another triangle, then they are congruent. So if I had two shapes like this one and then like this one, and I have these sides match up, these two sides match up, and these three sides match up, then we can show that these two triangles are congruent. Or you can see that I rotated this triangle clockwise 180 degrees and then translated it down, and then I'd get that same triangle. But now we're moving to these words, these three words, side, side, side. If I can find three matching sides, then I have congruent triangles. The second way is side angle side, abbreviated SAS. So that's shorthand or shortcut for if two sides and the included angle, okay, that's a big word, of one triangle are congruent to the corresponding sides and included angle of another triangle, then they are congruent. We emphasize included angle here, okay, so we should technically add that in, included. Because as you can see, for this triangle, the included angle has to be between your two sides, like that. The angle has to be in the middle between your two congruent sides. So like here, if we drew this out, we have one like this, and one like this. There's one side, here's one side, here's the other side, here's the other side. We have to have this angle be congruent. It's not going to work if we had this angle, for example, or that one. Okay, that's not going to work. But this order does. By SAS, has to be the one sandwiched in between. By similar logic, here's angle, side angle, ASA, and that's just like the previous one, but now it's an included side. Now your side has to be sandwiched between two angles. So angle, side angle, if two angles are and the included side of one triangle are congruent to the corresponding angles and included side of another triangle, then they are congruent. So in this case, let me draw a quick example like this, like that. Okay, don't mind the scale. So we have these two angles being congruent. We have this one being congruent. Now we have to have this side be congruent. Notice if we went backwards and we had this one and this one, for example, that's not going to work, as it is not included. This side is not between my two angles. So that's why it has to be this one. As we apply these three theorems, here's a short example. We have these three ways to show two triangles are congruent. So which one is it for this example here? We have two sides, okay, so we know it's not this one. It has to be one of these two. We look at their diagram and see that, oh, this one, PR, it's shared by both triangles. So that's our third side. You are congruent to yourself. PR is the same as PR. You are you. So we look, it has to be this one, three sides. And let's be careful with the core congruent statement here. PRQ. PRQ. So we have to go in that same order. P to R down to the lower one, which in this case is called S. So for this one, we reviewed side, 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 SSS, side, angle, side, SAS, and angle, side, angle, ASA. Here's 3 ways to show that 2 triangles are congruent.